In this video, we'll discuss the different ways to count with NumPy. We'll start with an array of random numbers between 0 and 3. That's a equals np.random.randint from 0 to 3, and we'll make 10 of them. There are three main functions we can use to count, and those are Python's built-in len function, NumPy's np.sum, and NumPy's np.countNon0. Let's try to use each of these to count the number of zeros in the random array. We can start by making a mask for the condition. We'll say that's mask equals, and our mask will be a is equal to 0. And then we'll print it out. The length of this mask is the same as the length of the original. We had 10 random values, so we have 10 Boolean values in our mask. But we can use the mask to select just the zeros out of the original array, and then len will give us the answer we're looking for. Copying these down. Len works if we use the mask to select from A. We can instead count the number of trues in the mask. When using np.sum or np.countNon0, true is always 1 and false is always 0. So the sum of the mask will give us 1 for each true and 0 for each false, adding up to the number of trues. So we can just plug in mask there. np.countNon0 works the same way in this case, counting all of the trues and ignoring all of the falses. np.countNon0 is more useful in datasets where 0 has a more significant meaning. If we are tracking days with rainfall in a desert, countNon0 would be the most straightforward way to count the number of days in which it rained at all. np.any and np.all are a little bit different. These both take an entire mask as input and output one Boolean value. np.any will return true if any of the elements are true, and np.all will only return true if absolutely every single element is true. The applications of these to one-dimensional arrays are fairly straightforward. We can print out np.any of our mask to see if any of them are true, or we can print out np.all of the mask to see if every single one of them is true. The place where np.any and np.all really shine is with higher dimensional arrays. I'll make an array called hourly, which tracks some statistic and provides one sample per hour. So we'll model that with np.random.randint, this time from 0 to 10, and we'll specifically ask for a shape that's 10 by 24. Here, each row is going to be a day, and each column is going to be an hour of the day. With this, we can see if any days have no zeros. So that's going to be np.any to see if any of the days satisfy this condition, and the condition is hourly not equal to 0. And we'll do axis equals 1 to get one value for each day. In this case, it looks like every single day had some value that wasn't 0. We could also see which hours of the day always have higher than average numbers, and we'll represent that with np.all, checking to see if hourly is greater than the average of 4.5, and then we'll specifically check axis equals 0. This tells us there were no days in which all of the values were greater than 4.5. These functions should round out your ability to answer questions about datasets.